In this program, you will see the actual foundation construction process, and you will come to understand that this process utilized some very thorough techniques for integrating all the foundation elements with the building itself. This integration of all the construction elements provides you with a strong and earthquake-resistant building. The first foundation element is begun by drilling holes 55 feet below the soil line. At approximately 55 feet down, the soil is dense and compact. This dense and compact soil provides a relatively stable layer in which to anchor the steel concrete piles. A large drilling rig was used to drill the holes to a depth of 55 feet. With this type of drilling technique, a removable bit is hammered into the head of the drill. As the soil is displaced by the drill, when the drill is at the prescribed depth of 55 feet, the bit is forced off by the pressure of the concrete that is being pumped in through the hollow center of the drill. With this drilling technique, when the concrete is poured into the hole, the relatively dense concrete spreads out into the surrounding soil to create a large bulbous concrete pile. A 55-foot-long steel I-beam was used to provide reinforcement for the concrete pile. The steel beam was hoisted above the hole by a crane. The steel beam was carefully lined up over the concrete-filled hole and lowered into the hole. This process, as you will see, is repeated 44 times. To ensure that the entire length of the steel beam was properly installed in the hole, a vibration device was used to push the steel beam into the hole. By placing this structural steel section into the concrete-filled hole, the concrete pile was given considerable strength. And by surrounding the steel beam with concrete, the steel beam was given extra strength and durability. Next, the steel cage was placed in the upper portion of each steel-reinforced concrete pile. These steel cages act as pile caps. The pile caps provide a connection between the steel concrete piles and the foundation above. As designed by the structural engineers, a total of 44 piles were placed in locations to best support and distribute the load of the building and foundation above. The importance of these 44 piles is that they give the building and foundation significant seismic stability. The entire building and foundation are resting on these steel concrete piles. The next foundation element is the steel-reinforced concrete grade beams. This steel and concrete skeleton evenly distributes and transmits the weight and load of the building and foundation slab onto the steel concrete piles. The top of each pile was incorporated into the entire grade beam structure. A complex steel rebar skeleton was constructed to connect the piles together. This technique gives the entire concrete grade beam structure rigidity and strength. It also facilitates the even distribution and transferal of the building's load onto the piles below. Next, concrete was poured into the wood frame mold over the steel rebar skeleton. After the concrete hardens, the wood frame was removed, revealing the finished grade beam structure. The areas between the grade beams were filled with soil and gravel to complete the bed for the next foundation element, the steel reinforced concrete foundation slab. This next foundation element is the steel concrete foundation slab. This slab rests on top of the grade beams, and the building itself rests on the foundation slab. Steel rebar rods were laid down in an interlacing grid pattern on top of the grade beams. Next, concrete was poured over this steel skeleton. By embedding the steel rebar skeleton inside the concrete foundation slab, the foundation slab was given considerable strength. The foundation slab was then made smooth to make way for the building structure itself. A total of approximately 78 truckloads of concrete, or 780 cubic yards, were used in pouring the foundation elements. The next step was to connect the walls of the building itself to the foundation slab. Steel reinforcement rods were embedded in the foundation slab. These rods were integrated into the concrete stem walls that are the base for all the wooden walls of the building. The wooden walls were bolted into the concrete stem walls by expansion bolts embedded in the stem wall. This provides a solid connection between the wooden walls and the foundation slab. The more support structures there are on the ground floor, such as support beams and walls, the more there is support for the entire building itself. To provide both vertical and horizontal load support for the areas of the ground floor, steel support beams were used to provide this needed support. The steel support beams were bolted into the grade beams below the foundation slab. These steel support beams at the ground floor of the building are directly attached to the grade beams. This demonstrates the solid connection of the support elements of the building itself with the foundation. The steel beams provide both vertical and horizontal support in the ground floor lobby area. In the garage, all the open areas are given support by large vertical and horizontal steel beams. This integration of wood and steel provides considerable strength to all these areas of the ground floor. You have now seen the actual steps involved in constructing the foundation of this building. Many extra and thorough steps were taken, from the steel concrete piles to the steel concrete grade beams, the steel concrete foundation slab, and the ground floor steel beams, all designed to provide you with a strong and earthquake-resistant building.